Welcome to the pre-recording of lecture 26 of MCS 260, Introduction to Computer Science. So this is the second half of the session 13, following the end part on modular modules and packages in Python. So today, or in this lecture, we are introducing object-oriented programming, which is a fundamentally different way of looking at computer programs. At first, it will be a little bit, or probably a whole bit different of what we have been doing so far. I will separate the design from the programming. So let's start. What is object-oriented programming? At the very basic level, it allows to create our own data types. So in Python, we have elementary number types, strings as well, then the tuples, the dictionaries, and the lists. Now, this is very powerful, but that actually does not really suffice. So we would like to represent real world entities, such as, for example, in the management of a library system, we would like to represent the real world objects, or at least the information that we need of the real world objects and also the real world people. We would like to represent this, but with customized data types. UML stands for Unified Modeling Language. This is a graphical language which is also available in Jupyter Lab to model, to draw, and to design object-oriented software. So UML is very extensive, and also in this course we actually do not really have sufficient time, and it is an introduction to computer science. So we will certainly only scratch the surface of UML, but it will suffice to already see its use. So we will limit the use of UML to two types of diagrams. There are the class diagrams, which describe what is in a class, and then there are the use case diagrams that describe which user can do what with a particular data object. So the program that we consider is actually a little bit longer, but it's still only a prototype. It's a prototype of a library management system. It's something that within the concept of this introductory programming course that we can present in its entirety. Okay, assuming everybody knows what a library is. So when we manage a library of books, so we have two types of users. We have the librarians, plural, and we also have the patrons, the customers of our library. So patrons, when they are logged in, they can view the catalog, check out books, and return books. These options are also available to the librarians, but the librarians can, in addition, add books to the collection, also delete books. They can also manage the people catalog. So cataloging people is not the right word here, but they are able to register new patrons of the library. This is a very simple management. So Python actually also is suitable for distributed execution, but here we will assume that our library is a small library and there is only one terminal and only one person uses the program at any given time. There will be a lot of queuing, but it's a personal library as well. Um, Here is our first UML diagram. This is the design of a class book. So we have to decide what type of information we wish to store for every book, and also what type of information, what type of operations will be executed on any object that is a book. So in this diagram, we will have a unique identification number for every book. Every book will be stored by its title and its availability status. There's much more that one can store from a book, but for simplicity, these three items will do. We can create a new book. That means make an instance, as we will say, make an object with that information. We can show the information about the book. We can check the availability of a book, whether it's available for checkout or not, and we can also change the availability of a book. So um, this is Python oriented. The bottom line has already the words that we will use in the implementation. So in some sense, the that's still too early to mention perhaps, but in Python you first define the constructor. That's with this underscore underscore init underscore underscore and then the arguments, and then you define the string representation. So in a way, one works incrementally. So we will present here in this lecture the entire class all at once, but typically this is built stepwise. Okay, we will have a class person where every person has also a unique identification number. A person has a name and a status. Is the person a librarian or not? So this status will be true or false. We can create a new person, so this sounds rather strange, but it again means that we will make an object that will represent a person in the real world. We can show the information, what is available. We can check the status and also change the status. Um, I should say that the identification number here corresponds to the PIN code of a. So this is kind of a dual use. It's not so much that. So again, this is a very limited design where I only wanted to store three data fields. In an actual library management, you would also have an address of each person. But here, the identification number will also serve as the uh, personal, the private identification number, the PIN number, that is actually also serving as the password to log into the system. Okay, then we have a list of books, and that is wrapped in the catalog. So we have introduced the principle of information hiding. That is also part here. When we think about books and people, we think essentially about lists. So a catalog will manage a collection of books. So we can add delete books, check in books, check out. This changes the availability status. We can show the collection, and there's also a search that can be done on the books. The class people. So we will have only one person that can be logged in. So we can prompt, so we can check who is currently logged in. So that is a data attribute of all the list of, we will store a list of persons. And there is an initialization with the root, so there has to be at least one librarian. Log on, log off are the operations, adding, deleting people, and one can also search. So here there are more methods, but this design is still allowing us to focus on the um, functionality of a particular component. So here is a second type of UML diagram. So it's a behavior modeling diagram of that type, but here it is a use case. So on the catalog, a librarian can do all operations. A patron cannot add and cannot delete any books. These are the privileged operations that only a librarian can do. So when logged in, a patron will not see these options to the catalog. The same happens for the people class. The people class is a collection of persons uh, that are known in this library. Everybody can log in and log out, but only the librarian has administrative privileges to add new users and to delete users. So this is the user administration that also is happening in databases. So here we will do everything in one in a collection of Python scripts, but you can see already the possibility for growth. Then here is the entire design. So there is one main program. There are essentially two main new data types, a data type to represent a book and another type to represent a person. The two boxes on top of the book and person are the collections. So in a way, this is also illustrating that there is one single top program. That's, if you can like, it's the main program, but the design of this application is essentially bottom up. So we think first about what it is that, what information should our program store about the application. The links, so there are not arrows. The links actually illustrate the import relations. So in some sense, the library manager, so the top program, doesn't really directly deal with objects of the type book or person. So, but interacts only through the catalog, only through or only through the list of people. So in a way, modular programming is a little bit more general, but also more fundamental than object-oriented programming. So it's good that we already know about modules, about the import, the way to do imports. Okay, what is object-oriented programming now? So it's a method of implementation in which the programs are actually organized as cooperative. Cooperative is important, collections of objects. So we have the objects and they are members of some class. So every object is an instance of a class. And the cooperation already hinted at this. So we have the objects, the classes, but then also the hierarchies. So every class, a class doesn't stand on its own, but it's kind of a piece in a hierarchy. So the hierarchy was illustrated in this application. So this is a fundamentally different way on how we thought about programs at the beginning of the course. So also computer science itself deals with the study of algorithms um, to compute in, to compute algorithms to compute. So to deal with information, if you like. But here we are still dealing with information. So it's mainly how the information is defined and described and transformed. It's actually not really done by algorithms, but it's done by objects. So often we distinguish between procedure-oriented programming, which is entirely focused on algorithms instead of dealing with the objects. So this is probably one of the most abstract slides in this part of the course, but this is important to illustrate the difference with the beginning of the course when we defined what is computer science and what is an algorithm. Algorithms are still very important in object-oriented programming, but they are more isolated within the functional attributes within the definition of the classes. What is actually much more important is the modeling of the real world situation that the program has to handle. All right, so some more terminology that I have introduced already. When one defines a class, one thinks about, and that is what we did to the first type of diagrams, we think about the data that we want to store, and we think about the methods that we want to apply on the data. So you see already that classes, when well designed, actually will um, not automatically, but in a good design, a class is actually just like a module. It will have a high cohesion. So all the operations that you can do on a particular object, that will be defined by the class to which the object belongs. A data attribute can be class-wide. So typically, um, every object has its own identification number. It has its own title. That's managed by the object. But then, if you want to have a unique identification number, your object, when you make a new object, you somehow need to refer to the number of objects that is already available. So you can make the count of totally available books, for example, you can make that a class-wide attribute. So a class-wide data attribute. That is very useful. So this is where the lists come in very handy. What we have covered also with the call by reference. So I will point at the code where we actually use this class-wide data attributes. There is the self that we will encounter when we look at the definition of classes. So self is a reserved word. You cannot use it as a name of a variable. It is used in the argument of a method, and it refers to the object to which the method is applied. So here we have actually already used a lot of object-oriented programming. So for example, when we sorted a list, a sort is a method of a list, of the class list. So when we apply the sort method to the capital L, the L is actually not known at the time when the sort method is written. The programmer had to refer to it as self. So there will also be an other that the other we will introduce in one of the later lectures. So that is other terminology. So we are thinking about programming in the large, but the first exercise is a very small exercise. So it is a very important exercise. It's the uh, most non-trivial and example, but non-trivial smallest example of a class application that I know. Suppose that you would want to have a list of counters. Of course, you can store them as a list of numbers, but you can make a counter, say, for the yes votes and the no votes. And then when we updated the tally of votes, and also in our quiz application, when we updated the tally, there was the possibility of error. When we updated the list of tallies, we could very easily miss and add the wrong index. Here actually we will have a separate instance of a class counter for the yes votes and for the no votes. So if we have good names, yes is an instance of the class counter and no is an instance of the class counter. And we increment whenever we have a yes or whenever we have a no. In doing this increment operation, in adjusting the tally, we are only working with one particular object. That is only working on the data that concerns that particular count. So when you make a counter, you initialize to 0, so that is the constructor. When the string representation will essentially produce a formatting string, and the add will just increment. So there will be three operations in this class counter: the init, the constructor, the initializer. You make a new counter, you show the value. So this is what happens. The string representation is what happens when you print the counter. And then you have the increment, the add. And that is already useful to get the essentials of working with classes. There is a rational there, and you can see that with the constructor, you should already normalize. This is to show how algorithms are actually embedded in the classes. So one of the algorithms we started with is Euclid's algorithm for the greatest common divisor. But when you make a rational number, say 4 over 2, you will actually have to represent it as 2 over 1. So that is the main goal here. Incorporate an algorithm, the greatest common divisor, inside a class. So the greatest common divisor will be a normalization operation that is not directly visible to the users of the class, but that is nevertheless used in the operations of the class. So there is the design and there is the writing of the code. So in programming in the large, the work gets more substantial, but you will get credit for making a good design. And actually, if the design is not good, then the implementation would also not be very good. So again, so this library manager is a prototype. What if you would use files? Which functions would start to change? Where would you make your modifications? Um, so let's think about this. So in a way, these four exercises are very important exercises. Um, we will see more on object-oriented programming, but this is a good start. Okay, I have prepared a Jupyter notebook. So here it is. So there are two parts. There is the first part on the UML diagrams. So here you see in a Jupyter notebook how I can show a UML diagram. So that is the first UML diagram. Perhaps I should show how I made this, and I will only show the diagram because I have actually not really used this all that much. But here is my diagram environment, so you can see I have this tab open. It took quite some patience, although I did everything within the hour, so it's not really that frustrating. It was a bit frustrating because I had not really that much prior exposure, and I needed a little bit do things a little bit in a hurry today. But you see from the UML, so there is the class name. There is the class name diagram. Perhaps I should shift up that a little bit to make it clear. So we have used the draw. We have used the draw to do the um, flow charting. Here we will use this, you will only need a couple. So here you see the stick figure that we will use in the use case diagrams. If you have never used it, so again, if on an exam you are requested to um, make a drawing, then it can be truly frustrating if you have never done it. But as part of the exercises, please spend at least 1 hour to reproduce these diagrams. I will also post them. Um, there is the other one. So here you see the use case diagram for the catalog. What the librarian can do, the librarian can apply all the operations, and then the patron can only do the checkout and the check-in. So this is on the collection, on the catalog of books. Okay, so this is the design. I will not repeat, so the slides are more elaborate. So I made the slides before I was using diagram, but here you see the essence of the two types of diagrams and also how you can use this to design. Um, the general BPMN is also useful for the modular design. So the design that I haven't shown here, but it is on the slides. And perhaps I started with that at the end. But here you see that the overall design, so looking at it at the global level, it's not so different from the diamond design that I started with the modular design. So we have here the global design of the program. Okay, so it's good to keep that picture in your head when I'm going through the code. So I will use the Jupyter notebook to illustrate the similarity between modules and working with classes. Now, it is possible still to do everything in one Python script. Programs that we see are still relatively small, but it's very good practice to have one class in one file, and you can also use the class as a program to do a very simple test. Um, every module must be documented. So you see here I have the description of the module. It exports the definition of a class to represent a book. In words, I describe the design, what what every object stores. So here is the view. So we have the constructor when we add a new book. There is the optional argument, a title. There is the string representation. So typically one always starts by defining, or here they are already defined because of this underscore underscore. We are overriding is the technical term. We are overriding the definition of the constructor and the string representation. Then there is the changing of the type of availability, and then there is the checking of the availability. Um, Here you see also the class wide data attribute. So every object will store the reference of the count. And this is very useful when one constructs. So here is the user perspective. Um, we have two books in our library, so two optional books that we recommend. So for the computer literacy, we have Computer Science an Overview, and for the Python programming, there is the book Python Programming in Context. And you see, when I make these two books, when I ask for the string representation, we have again the column format, one, the first book to the second book. Okay, now I should actually show the class book, the source code for this. So here everything is in the current folder, so I have not, um, so you see there is only the class here. I could have added code that does a very simple test. So in some sense, the code that is in the Jupyter notebook could also have been added here to make this a little bit more self-contained. I can then run this class book as a program. So when running as a program, it would just show this example. Okay, there is the constructor. So first of all, what does every module has? Should have. It has a documentation string. So the first lines here are the documentation string of the module. So this is what we saw when we did the help. Um, I can't resist of fixing here this uh, typo. So then we have the data attributes. So the data attributes are for the class are defined in the constructor. So there is the key, there is the title, and then there is the availability. So when you define the constructor, so the word self must be there. So if the optional argument, the book title is provided, then we will select it from the tuple. So it's an optional argument. Otherwise, we will prompt for a title. So we don't have books without title. There is the data white attribute, and here you see how it is used. So we get to it to the count. So count is the reference. And we have here with our first book, we have 0 sitting in there. But you see that this count is updated. Um, so when we call the constructor a second time, then we can the count will actually have been updated to 1. So this is a very nice solution to um, have unique identification numbers to work with class-wide data attributes. So the data attributes are defined when you define the constructor. Then we have the sentence that is printed when you asked for the uh, when you ask for the string representation. So in some sense, these two operations is something that you ask right away. So something that you will define as from right from the beginning before you think about all the other methods. In the spiral way of developing software, test frequently, early, and often. So as soon as you have something, do it. So outside, so I should probably have indicated this also here. So let me add this. So when we have a book, so we have here the string representation, but I can essentially query also the key of a book. So the key is 1, so that's the unique identification number. There is the title of the book, and then there is the availability field. So it is available. So you can get through the information just with the dot. Just you can see it's just a data attribute, just as the method is a data attribute. I should also have indicated I imported class book. So to make a book, I have to do class book dot book. Later, I will from class person, I will import person. Then I don't need to write class person dot person. There are applications where you may prefer one way over the other. Okay, so class book has then the method check, so you can check returns true or false. So just to make sure that before you change the status, and changing the status is flipping the status. So there is a check in and there is the check out, but it doesn't. You cannot check out a book that is already checked out. So if you change the status, you flip the availability flag. So these two here are the two methods on the course, on the two methods on the object book. One is what they call a selector. The other one is a modifier. So in some designs, you indicate often which methods that are going to select or which methods are going to modify the object. All right, so this is our first class. Um, so it's not large. So let me now go immediately to the other class, the class person. So here we will initialize a person with a name. And here I used the dictionary. So when the name is in the dictionary, then I will select it. Otherwise, it will be prompted. So how this is again be used, perhaps I should not flip too much back and forth, but here is perhaps the interface. So I will import from class person. So class person is the name of the module. That is not at all standard, so I named it like this. So this is the name of the file. Person with a capital P is the name of the class. So here you can see that I make a person. The person is a librarian. It's me, and the PIN number is 1234. When I ask for the string representation, here it is. It says the name with PIN number 1234 is a librarian. The other person, the Q, so P and Q are objects now, are references to objects. So it's important, again, there are many things that need to be explained, but when you call person, you are executing the underscore underscore init underscore underscore. So person with a capital P is the name of the class. What gets executed when you make excuse me, when you make a new instance of the class, this is the code that is executed as defined by the init. So the P and the Q are actually the self. So you have the p.name, p.pin, p.status that are defined as the data attributes. In this particular case, when all the three fields are there, so using a Jupyter notebook interactively is kind of tedious, so it's better to do it with the keyword arguments. Here you see the three keyword arguments are there in the dictionary. I listed them in the order, logical order, name, pin, status, but they could be in any order here. Okay, so that is the class person. The string representation shows the name, the pin, essentially returns one string here. Then we can, just like with a book, we can check on the status. So this is very useful later on if we want to build our main programming. Depending on the status of the person, we will show certain menu options or not. So you see that this is again data encapsulation and information hiding. So the main program will only check on, will actually not really have the actual access to the data, but has the ability to check things. You can change the pin. You can also change the status. So you can upgrade a patron to the librarian status. Or you can downgrade a librarian to a patron. Okay, our first two classes. So there is some repetition here, but I hope that you also see that the effort that we spent on making functions work, that the keyword arguments and the optional arguments, that this is all coming to a good application here. Okay, what is next is the catalog. So I can add the books to the catalog. Um, so I have the two books here. Um, in the string representation, so I make a new catalog. So catalog is defined here. So this is the class catalog. The class catalog essentially is a wrapping, so it encapsulates a list. So that's actually what it does. We are viewing a list now as um, we are viewing, we are using the list, the Python list, to store a list of books. Why? Because we are Python programmers and lists are the natural application for uh, collections. So dictionaries could have been used as well, but then there might have been the duplication that in the catalog we have a key for every book, but then the book itself also stores its key. So one needs to be a little bit careful about this. So there was the last exercise. If you would work with files, what would change? One of the modules that would change would be the catalog. Working with files could be a transition to go to a database. So you would essentially, and then it makes sense to have a different identification number to the database, the key in the database, and then the number of the book. So the number of the book could be a logical, chronological order in which the books were added to the library, whereas the key in the catalog could be referring to something else, could refer to the way dictionaries, the information is stored. Um, you see, in essence, a catalog is just a list. So you start by defining in it the string representation and the add. So that is what I showed in this Jupyter notebook. So this is also programming by extension, so the spiral-like way of designing software. Um, Later functionality that gets added is the searching, the checking out, the checking in, and the deleting of the book. Um, these are very good algorithms. So we have seen how to, so in the review and perhaps also during the first midterm exam, you were asked for the algorithms to locate something in a list. So these are these things that are used here. There is the popping that is used to delete an item. So you can delete an item based on the key. So you can checking in is searching. So here you see how certain methods are used as helper functions also in the checking in, checking out. So you start by searching in the book. And then you give error messages. So the none is another keyword in a method if you return something. So here we have to return the key, but sometimes there is no key if the book is not in the collection. We could generate an exception. So that's a design question, but instead we will return none and then we can check on this. Um, so you see that this is a way how algorithms come in. So it's another way of organizing algorithms. But the algorithms are now encapsulated as well in the methods. So with the modular design, functions were defining algorithms, or algorithms are defined by functions. Here, the algorithms are defined by methods. The additional benefit that this has is that we are working on the self. So by passing self, we pass all the data attributes. So here for a book, we have the availability, we have the key, we have the title. In a function, we would need to provide this information as a tuple. So you can always represent everything by a tuple. You could represent a book by a tuple, but when you would be limited to work with functions only, it would be kind of starting to get very tedious to work always with these tuples. So each time you would need to be very careful about passing the correct tuples as arguments. Here you have the self. Also, the methods are tightly within the definition. So here we encapsulate both the data and the methods on at the same spot. So this also refers to the high cohesion. So the catalog and the books, they are coupled together. So there was no coupling between the catalog and the people. So the management of the user administration is entirely separate from the management of the book collection. So this is another interesting separation that makes for a high cohesion and a low coupling. The design for change I have illustrated. So at the very beginning, you start with this first three methods. So a catalog management already involves some searching and some operations, some algorithms, but these algorithms they are now implemented via the operations on lists. So here you have the loops on the lists with the in method when you search on the key. Once you have found a book, you have the key, you return actually the entire book, and then you can change the book to check it out or to check it in. Notice that there is the extra check. Um, there is the checking out if the book that is returned equals none or not. You can also check on whether any variable has actually the type of books. So there is this is instance. So if what is returned by book is actually an instance of the class book. So that refers to the membership. So you can check whether a variable belongs to a class, whether an object, a variable that refers to an object, is that object now belonging to the class? Is it an instance of the class, is the terminology. All right. What I couldn't show very well in the Jupyter notebook is the way how the people are defined. So there is the initialization. So there is the first time when you create your people collection, your collection of persons, you actually need to design a root person. Who's who is actually the data attribute that is managed. So again, the people class is an encapsulation of a list. So here it's called the who's who. Initially, there is the root with pin number 0. So we have to remember this when we run the program for the first time. The current is initialized to the empty string. So it stores the route and the information about the current. So it's a little bit similar when you are a system administration on your computer. You have the system administrator the very first time when you log into your computer, and then you can add people, and you can then you can add librarians. So you still have the root. Perhaps pin 0 is not a good pin, but it's good enough for this demonstration. We are not going to um, um, lose it. So you could see the code for the login. Um, so it checks whether the person has already been added to the collection of people. It checks then on the logging in whether the PIN, the password, the identification number, this personal identification number, um, is a good match. So this is a first uh, illustration of password management. Again, not very secure. So in the question on how would you change, which files would you change, which modules would you change when you go to files, the class people would be something else that you change. And for the security here, you would encrypt the passwords. So you would actually not hard code them into the way this is done here. Um, because there is not much information hiding in Python proper. The people, actually, the collection of people is actually stored in the list. So when I have a collection of people, I can actually still get to each person via the referencing of the elements in the list. So I'm running over time, but this is the second part of the 13th session, and the first part was rather, I was finishing in 40 minutes. So here I can afford to run a little bit over time. So here you see now the main program. The main program has a very simple structure. It's a little bit similar to the quiz. So if you are beginning to become a programmer, it's learning a new language, but it's also kind of learning this programming paradigms or this idioms, the models in which you are building a terminal application. So you have this while true loop, the while true loop that we introduced with the simple game of guessing a secret. We also saw it with the quiz. We see it here again. So the difference here is that we initializing the catalog, initializing the people. So using this program is not very interesting if you don't have files. You always start from scratch. So with files, you have persistent data, and you can make this a lot more interesting. So what does this program do? It shows the menu, and the options that will be shown will be depending on this use case diagram. Depends on who's who, the menu will be shown, and also the actions will be shown. So it depends whether you are an instance of the librarian or an instance of the patron. So, and this is coded up with this +1 or -1. So if you're not yet logged in, so you have to return. So you only do this. So there is this coding here. So the 0 is a patron. The +1 is when you can show more menus. Note here that the order of the operations is only defined here. It's in the top program. It's in the layout, essentially. So in the catalog or in the people uh, class, we didn't actually order, we didn't label the methods here. So there is an order, but it's kind of arbitrary still. So it's still up to change. So there is the showing of the menu, which makes use of this use case diagram, which follows it. And then there are the actions. The actions here will actually depend on also the um, the choices that were made. Okay, I think that this might have gone a little bit too fast still, but I hope that I have given the essence of an idea of what the uses of object-oriented programming. Going back to the slides, please try to do the counter. So as a very first exercise. So I will recommend that this is also being done in the lab sessions. And this is a very good example to get started with object-oriented programming and classes. So it's a much more elaborate and refined model, more subtle, a lot more terminology, a lot more things that can go wrong. And when they do go wrong, when you have a wrong design, things go wrong very badly. But if you have a well designed uh, design, that's why the frustrations with the diagrams often pay off. You have to think, do I really want to do it this way? Um, that will often lead to much, much better code. So there's a lot more work that you need to do to essentially often see the same results, but you get a much better program and it will scale. So in Python is a good language for high productivity, but also for prototyping. In this class, we will only do prototyping. We will only present small applications, but in the sequel to this course, we will actually see the tools that are necessary to build this into a realistic looking software. Okay, perhaps I should run it, or so this is lecture 27. So here we have the lib classman. So what's my name here? Is it not root? My pin is 0, and here you see what I can do. So I can show the collection, but there is actually nothing in there. So this is already a very bad application. So let me show the root, the pin. Actually, the first thing that you actually do is that you add a new user. So you add me, 1, 2, 3, 4, and it is a librarian. And now I will log off as root. So I will log on as me and 1, 2, 3, 4. And now I can add a book. So add a new book as a librarian. Oops, something actually went wrong here. Um, okay, so this program still has some problems. Um, so I have to check what is going on, but I will do this before the live presentation starts. So, and for me, it's now time to also finish off this pre-recording. It's actually an hour. Um, what was most important in this lecture is actually the um, definition of object-oriented programming. This is rather abstract, but I hope that the design, so here the design kind of makes it clear what the object-oriented programming can do for applications.